When Americans hear the term fifth-generation fighter, a few familiar names usually come to mind. The F-22 Raptor. The F-35 Lightning II. These aircraft represent decades of investment, engineering, and doctrinal thinking about how the United States expects air combat to be fought. They are not just machines, but symbols of how American air power has evolved since the Cold War. So when another nation introduces a fighter often placed in the same generational category, it naturally raises questions. Why was it built? What problem was it designed to solve? And how does it fit into the larger picture of modern air combat? One of the most discussed and most misunderstood answers to those questions is Russia's Su-57. The Su-57 is frequently mentioned in headlines, comparisons, and online debates. It is often placed side by side with American aircraft and evaluated through familiar lenses: stealth, speed, maneuverability, and cost. But these comparisons rarely provide context. They assume that every country approaches air combat the same way, under the same conditions, with the same priorities. In reality, aircraft design reflects far more than technology alone. It reflects geography, history, budget realities, and strategic assumptions about how wars might actually be fought. This is why the Su-57 matters to American audiences. Not because it represents a direct rival in every sense, but because it offers a different perspective on the same problem the United States has been trying to solve for decades: how to maintain effective air power in an increasingly complex and contested environment. To understand the Su-57, it helps to first understand the moment in which it was conceived. The era of simple air superiority is long gone. Modern air combat is shaped by long-range sensors, advanced air defenses, electronic warfare, and networks that connect aircraft, satellites, ships, and ground forces. In this environment, speed alone is not enough. Stealth alone is not enough. And even the most advanced aircraft cannot operate effectively in isolation. The United States responded to this reality by emphasizing stealth and information dominance. The F-22 and F-35 were designed to see first, decide first, and act first, often without being detected. Russia approached the same reality from a different starting point. Its geography is vast. Its airspace is enormous. Its defense priorities emphasize layered systems, long-range engagement, and flexibility across multiple mission types. The Su-57 reflects these realities. Rather than copying American designs, it represents a different set of trade-offs. It blends reduced observability with speed, range, and maneuverability, while incorporating modern sensors and avionics intended to operate within a broader system of air defense and support assets. This difference in philosophy is often lost in popular discussion. Too often, the Su-57 is reduced to a single question: is it better or worse than American fighters? That question may be easy to ask, but it is rarely useful. A more meaningful question is this: what does the Su-57 reveal about how different nations think air combat will unfold in the future? For American viewers, this question is especially relevant. Understanding how other countries approach air power helps clarify why the United States made the choices it did, and whether those choices will remain effective as technology and strategy continue to evolve. This documentary is not about ranking aircraft or declaring winners. It is about understanding context. It is about examining the Su-57 as a product of specific assumptions, constraints, and goals, and using that understanding to better grasp the broader evolution of modern air combat. Along the way, we will look at how the Su-57 fits into Russia's Air Force, how it compares, in philosophy rather than hype, to other modern fighters, and what its development suggests about the future of air power. We will also address common misconceptions. Advanced aircraft are often surrounded by myths, exaggerated claims, and oversimplified narratives. Some portray them as unstoppable machines. Others dismiss them as failures based on incomplete information. Reality is almost always more complex. The Su-57 is neither a miracle weapon nor an irrelevant experiment. It is an evolving platform shaped by real-world constraints and strategic thinking. And that is precisely why it is worth understanding. For American audiences, learning about the Su-57 is not about admiration or criticism. It is about perspective. It is about seeing how different paths can emerge when nations confront the same technological challenges under different circumstances. In a world where air combat is increasingly shaped by systems, networks, and long-term adaptability, understanding those differences matters more than ever. As we move forward in this documentary, we will explore how the Su-57 was designed, how it is intended to be used, and how it fits into the broader landscape of modern military aviation. But before diving into technical details, it is worth keeping one guiding question in mind. What does the Su-57 really represent, and what doesn't it? That question frames everything that follows. Aircraft are never built in isolation. Every combat aircraft reflects the environment in which it was conceived, not just the technology available at the time, but the geography it must operate over, the budgets that support it, the history that shaped its doctrine, and the strategic assumptions its designers believe will define future conflicts. The Su-57 is no exception. To understand why it looks the way it does, and why its capabilities emphasize certain traits over others, it is essential to step back from comparison and examine the strategic context that shaped its development. This context is often overlooked in popular discussion, particularly when aircraft are evaluated primarily against American standards. Yet it is precisely this difference in perspective that makes the Su-57 relevant to American audiences. Russia's geographic reality is fundamentally different from that of the United States. It is a country with vast land borders, expansive airspace, and a long history of defending large territorial areas rather than projecting power across oceans. This geographic scale influences how air power is structured and how aircraft are expected to operate. Rather than focusing primarily on expeditionary operations supported by global basing networks, Russian air doctrine has traditionally emphasized homeland defense, regional deterrence, and layered protection of critical areas. The Su-57 reflects these priorities. Its design assumes operations over long distances, often in coordination with ground-based air defenses and supporting systems. This differs from the American model, which often emphasizes forward deployment, carrier-based aviation, and sustained operations far from home territory. Budget realities also play a significant role. The United States operates the world's largest defense budget, allowing for extensive research, development, and procurement across multiple specialized aircraft types. Russia, by contrast, has had to prioritize carefully. This does not mean accepting inferior technology, but rather making deliberate choices about where to invest limited resources. As a result, Russian aircraft programs often seek versatility, adaptability, and longevity rather than large production volumes of highly specialized platforms. The Su-57 was developed with these constraints in mind. Instead of replacing an entire fleet at once, it was designed to complement existing aircraft while gradually introducing newer capabilities. This phased approach reduces risk and allows for adaptation over time. History also matters. Russian air combat doctrine has been shaped by decades of experience operating in contested environments, often under the assumption that adversaries would possess strong air defenses and electronic warfare capabilities. This history reinforces an emphasis on survivability through multiple means: speed, maneuverability, electronic countermeasures, and coordination with other systems rather than reliance on a single attribute. The Su-57 embodies this layered approach. Rather than treating stealth as an absolute solution, it incorporates reduced observability alongside other survivability measures. This reflects a belief that future conflicts will involve rapidly evolving detection technologies, making flexibility more valuable than dependence on any one advantage. Doctrine further influences how the Su-57 is intended to be used. American air doctrine often centers on achieving air superiority early, followed by sustained operations supported by logistics, intelligence, and coalition networks. Russian doctrine places greater emphasis on denying adversaries freedom of action, protecting key areas, and complicating enemy planning. In this framework, the role of advanced fighters is not necessarily to dominate the skies alone, but to contribute to a broader defensive and deterrent system. Understanding this difference helps explain why direct comparisons between aircraft can be misleading. When the Su-57 is measured solely against American fighters designed for different missions and operating assumptions, important context is lost. This does not mean that comparison is useless, but it must be grounded in an understanding of why each aircraft exists. For American viewers, this strategic lens offers valuable insight. It highlights how different systems think. It shows that technology does not develop in a vacuum, and that design choices reflect priorities shaped by real-world constraints. By examining the Su-57 through this context, we gain a clearer understanding not only of the aircraft itself, but of the broader landscape of modern air combat. As we move forward in this documentary, this perspective will remain essential. It allows us to evaluate capabilities without bias, to appreciate differences without exaggeration, and to better understand how air power continues to evolve across different strategic environments. The term fifth generation is often treated like a checklist. Stealth, advanced sensors, networked operations, survivability in contested airspace. In many discussions, an aircraft either meets these criteria or it does not. This approach makes the concept easy to understand, but it also creates confusion. The idea of a fifth-generation fighter was never intended to function as a strict technical standard. Instead, it describes a shift in how air combat is approached and how modern aircraft are expected to operate. Understanding this distinction is essential when evaluating aircraft like the Su-57. Rather than representing a single design formula, fifth-generation thinking reflects a set of overlapping ideas. These ideas emphasize integration over isolation, awareness over raw performance, and adaptability over specialization. At its core, modern air combat has moved away from individual aircraft acting alone. Fighters now operate as part of interconnected systems that include sensors, data links, command and control assets, and supporting platforms. This shift changes what matters most. Reduced observability, often referred to as stealth, is one of the most visible elements of fifth-generation design. By lowering detection ranges, stealth can provide time, flexibility, and tactical options. However, it is not absolute, and it is not effective in isolation. Advanced sensors represent another key element. Modern fighters rely on radar, infrared systems, and passive sensors to build a picture of their surroundings. These inputs are increasingly fused into a single, coherent display that reduces pilot workload and speeds decision-making. Networking is equally important. The ability to share information with other aircraft, ground forces, and command systems allows individual fighters to contribute to a larger operational picture. This shared awareness often determines outcomes before any weapons are used. Survivability ties these elements together. Rather than relying on speed or maneuverability alone, fifth-generation survivability is built through layered approaches. These include reduced detectability, electronic warfare, coordination with other assets, and flexible tactics. Crucially, different nations place different emphasis on each of these elements. The United States, for example, has prioritized low observability and network-centric operations. Aircraft like the F-22 and F-35 were designed to operate within extensive global support structures and coalition networks. Other nations operate under different assumptions. Geography, budget constraints, existing force structures, and strategic doctrine all influence design priorities. As a result, fifth-generation aircraft developed outside the United States may reflect different balances among the same core ideas. This is where the Su-57 fits into the discussion. The Su-57 reflects one interpretation of fifth-generation concepts rather than a direct copy of Western designs. Its development emphasizes a balance between reduced observability, maneuverability, speed, and system integration. Rather than treating stealth as the defining feature, the Su-57 incorporates it as part of a broader survivability strategy. This approach assumes that detection technologies will continue to evolve and that flexibility across multiple domains will remain important. In terms of sensors and avionics, the aircraft is designed to gather and process information from multiple sources. The goal is not simply to detect targets, but to operate effectively within a wider system of assets. Networking capabilities support coordination with other platforms, reinforcing the idea that modern fighters do not operate alone. These choices do not represent a rejection of fifth-generation ideas. Instead, they illustrate how those ideas can be adapted to different strategic environments. The question, is it really fifth generation, is therefore less useful than it appears. A more meaningful question is how an aircraft applies fifth-generation concepts to meet its intended role. When viewed through this lens, the Su-57 aligns with the broader generational shift, even though its design priorities differ from Western counterparts. This understanding helps clarify why debates about generational labels often generate more heat than insight. By moving beyond checklists and focusing on underlying principles, it becomes easier to evaluate aircraft without resorting to oversimplification. For viewers, this perspective reduces confusion rather than inflaming debate. It encourages a more nuanced understanding of how modern air combat is evolving and why different solutions can exist within the same generational framework. As the documentary continues, this context will remain important. It allows us to examine design choices, capabilities, and limitations with clarity rather than assumption. In modern military aviation, understanding the ideas behind the label matters far more than the label itself. Russian fighter aircraft have long reflected a distinct design philosophy. Rather than focusing on a single defining characteristic, designers have traditionally emphasized a balance of agility, range, flexibility, and robustness. This approach was shaped by geography, operational history, and assumptions about the environments in which these aircraft would be expected to fight. The Su-57 continues this tradition, while also incorporating newer concepts associated with modern air combat. Understanding why the aircraft looks the way it does requires examining the logic behind its design, rather than judging it against a single external standard. Historically, Russian and Soviet fighter design placed a strong emphasis on maneuverability. Aircraft were expected to perform across wide flight envelopes, maintain control at low speeds, and operate effectively in complex, dynamic environments. This emphasis reflected expectations that combat might involve short reaction times, contested airspace, and rapidly changing conditions. At the same time, range and endurance were critical considerations. Russia's vast territory meant that fighters often needed to cover long distances without relying on dense networks of forward bases. As a result, internal fuel capacity, aerodynamic efficiency, and mission flexibility were prioritized. These historical priorities remain visible in the Su-57. While the aircraft incorporates reduced observability, it does not treat stealth as the sole organizing principle of its design. Instead, stealth features are integrated alongside aerodynamic shaping that supports maneuverability and efficient flight. This balance reflects a belief that future air combat will demand multiple forms of survivability rather than reliance on a single advantage. The Su-57's overall shape illustrates this philosophy. Its blended airframe is designed to manage airflow efficiently across a wide range of speeds and angles of attack. This supports controlled handling during aggressive maneuvers while also contributing to reduced radar reflections from certain angles. Rather than adopting extreme shaping optimized exclusively for low observability, the design reflects a compromise intended to preserve performance across diverse mission profiles. Advanced sensors and avionics also play a central role in shaping the aircraft. Modern fighter design is no longer driven solely by aerodynamics. Sensor placement, field of view, cooling requirements, and integration with electronic systems all influence external form. The Su-57's airframe accommodates these requirements while maintaining structural strength and internal volume for fuel and systems. Internal weapon bays represent another deliberate design choice. By carrying weapons internally during certain missions, the aircraft can reduce its detectability while preserving aerodynamic efficiency. At the same time, the option to carry external stores provides flexibility when stealth is less critical. This dual approach reinforces the idea that the aircraft is designed for adaptability rather than a single operating mode. Material selection further reflects intentional trade-offs. Advanced composites and modern alloys are used to reduce weight, manage structural loads, and support durability over long service lives. These materials also play a role in managing signatures and supporting maintenance requirements. Rather than pursuing the lightest possible structure, the design emphasizes resilience and upgrade potential. From an engineering perspective, this approach prioritizes long-term adaptability. The Su-57 was conceived as a platform capable of evolving over time. Its design allows for incremental upgrades to sensors, avionics, and mission systems without requiring fundamental structural changes. This philosophy recognizes that threats, technologies, and tactics will continue to change over the aircraft's service life. For American audiences, this design logic offers a familiar engineering perspective. Every complex system involves trade-offs. Optimizing for one attribute often means accepting limitations elsewhere. The Su-57's appearance reflects a series of deliberate choices made to balance competing priorities rather than maximize a single performance metric. This helps explain why the aircraft may look different from Western counterparts. Rather than indicating a lack of capability, these differences highlight alternative assumptions about how air combat may unfold and what capabilities are most valuable in that context. Understanding this design philosophy provides a clearer framework for evaluating the aircraft. Instead of asking whether it matches another fighter's strengths, it becomes more useful to ask how well its design supports its intended role. As the documentary continues, this perspective will help make sense of the Su-57's systems, performance characteristics, and operational concepts. The aircraft's form is not accidental. It is the physical expression of a specific way of thinking about modern air combat, one shaped by history, geography, and engineering judgment. Discussions about modern fighter aircraft often focus on a single question: which one is better? That question is usually framed around visible traits such as stealth, speed, or maneuverability. While these characteristics are important, evaluating them in isolation can be misleading. A more useful approach is to understand why different aircraft emphasize different priorities. This perspective is especially helpful when comparing Western fighters such as the F-22 and F-35 with aircraft like the Su-57. Western fifth-generation fighters have generally prioritized stealth as a foundational design principle. Reduced observability shapes nearly every aspect of their airframe, from external geometry to internal layout. The goal is to delay detection, reduce tracking accuracy, and create tactical advantages before an engagement ever begins. This emphasis reflects assumptions about modern warfare. Western air doctrine often envisions early access to contested airspace, supported by extensive intelligence, surveillance, and command networks. In this context, minimizing detection is seen as a critical enabler for mission success. The F-22 and F-35 embody this philosophy. Their designs optimize for low observability across a range of conditions, often accepting trade-offs in other areas to preserve stealth characteristics. The Su-57 approaches this balance differently. Rather than treating stealth as the dominant organizing principle, the Su-57 balances reduced observability with speed and maneuverability. This reflects a different set of assumptions about how air combat may unfold. In this framework, stealth is valuable, but it is not relied upon exclusively. The aircraft is designed to retain high performance across a wide flight envelope. Speed allows for rapid repositioning and engagement flexibility. Maneuverability provides options in complex environments where engagements may become unpredictable. These qualities are not remnants of outdated thinking. Instead, they represent an acknowledgement that modern combat environments are dynamic. Detection technologies evolve, engagement ranges vary, and encounters do not always follow idealized scenarios. By preserving multiple avenues for survivability, the Su-57 reflects a layered approach. Stealth contributes to survivability by reducing detection. Speed and altitude expand tactical options. Maneuverability enhances control and responsiveness when conditions change. None of these elements alone define effectiveness. The key difference lies in how much emphasis is placed on each. For Western fighters, stealth often takes precedence. For the Su-57, stealth is one element within a broader performance balance. This does not make one approach superior. It reflects different assumptions about how combat might unfold and what capabilities are most valuable under those assumptions. Comparisons that ignore these underlying assumptions risk oversimplification. An aircraft optimized for one operational environment may not be optimized for another. Doctrine, geography, and supporting systems all influence which trade-offs make sense. For American audiences, this distinction is important. It highlights that design choices are rarely accidental or indicative of weakness. They are responses to specific strategic and operational requirements. This perspective also helps explain why debates framed around who would win often generate more heat than insight. Air combat is shaped by systems, coordination, and context as much as by individual aircraft characteristics. The Su-57's balance of stealth, speed, and maneuverability reflects one interpretation of these realities. Rather than viewing this balance as a compromise in a negative sense, it is more accurate to see it as a deliberate choice. Design choices reflect doctrine, not weakness. Understanding this principle allows for more meaningful discussion of modern fighter design. As the documentary continues, this framework will help place future comparisons and evaluations in proper context, focusing on how aircraft are intended to be used rather than how they rank in abstract comparisons. Modern air combat is increasingly about information, not just weapons. While speed, stealth, and maneuverability remain important, they no longer determine outcomes on their own. In many cases, engagements are decided long before aircraft come within visual range, shaped instead by who detects whom first, who understands the battle space more clearly, and who can coordinate actions more effectively. This shift has fundamentally changed what it means to build a modern fighter. Today, the real battlefield is informational. Sensors, data fusion, and coordination now form the backbone of air combat effectiveness. Aircraft are no longer evaluated solely by their physical performance, but by how well they collect, process, and share information. This reality underpins the design of the Su-57. Rather than being conceived as a standalone fighter acting independently, the Su-57 is designed to operate as part of a broader system. Its avionics and information architecture reflect this assumption. At the most basic level, modern fighters rely on multiple sensors to observe the environment. Radar systems provide long-range detection and tracking. Infrared sensors offer passive awareness without emitting signals. Electronic systems monitor the electromagnetic spectrum for threats and opportunities. Individually, these sensors provide fragments of information. Together, they form a more complete picture. This is where data fusion becomes critical. Instead of forcing pilots to interpret raw sensor inputs separately, modern avionics integrate data from multiple sources into a unified representation of the battle space. This reduces workload and accelerates decision-making. The goal is not simply to see more, but to understand faster. The Su-57's avionics architecture is built around this principle. Information from onboard sensors is processed and organized to support situational awareness. This allows pilots to focus on tactical decisions rather than data management. Equally important is the aircraft's ability to share information. In modern air combat, individual awareness is valuable, but shared awareness is decisive. Fighters that can exchange data with other aircraft, ground systems, and command platforms contribute to a collective understanding of the battlespace. This networked approach allows forces to act coherently rather than as isolated elements. The Su-57 is designed to operate within such networks. Rather than functioning as a solitary hunter, it contributes sensor data and receives information from other assets. This cooperative model reflects an understanding that modern conflicts are system-level contests rather than individual duels. For American audiences, this concept is familiar. Network-centric warfare has long been a cornerstone of U.S. air doctrine. Platforms like the F-35 are often described as flying sensors as much as fighters. The Su-57 reflects a similar recognition of information's importance, even though its integration occurs within a different force structure and strategic framework. This distinction matters. Networked operations depend not only on aircraft design, but on supporting infrastructure, doctrine, and coordination. How information is used can vary significantly depending on the broader system in which an aircraft operates. The Su-57's role within its system is shaped by assumptions about contested environments, electronic warfare, and layered defenses. Rather than assuming uninterrupted access to information dominance, its design acknowledges that networks may be challenged, degraded, or contested. This reinforces the importance of flexibility. By combining onboard processing, sensor integration, and coordination with other assets, the aircraft maintains options even under less than ideal conditions. This layered approach mirrors broader trends in modern military thinking. Resilience, redundancy, and adaptability are increasingly valued alongside raw capability. From an authority perspective, this emphasis on information aligns with how contemporary conflicts are analyzed. Modern warfare is often described as a competition over decision-making cycles. The side that observes, understands, and reacts faster gains significant advantages. Aircraft like the Su-57 are built with this reality in mind. Their value lies not only in the weapons they carry, but in how effectively they contribute to understanding and shaping the battlespace. As this documentary continues, the role of information will remain a recurring theme. Whether discussing operational use, comparisons with other aircraft, or future upgrades, the ability to manage and exploit information will remain central. In modern air combat, control of the skies increasingly begins with control of information. Advanced military aircraft are rarely used in isolation. In modern air operations, fighters operate as part of coordinated systems that include surveillance assets, electronic warfare platforms, ground-based defenses, command and control networks, and support aircraft. Understanding how an aircraft would actually be used requires examining its role within this broader framework. The Su-57 appears designed with this reality in mind. Rather than being intended for mass deployment across every mission type, it is best understood as a selective use platform, one employed when its specific capabilities provide meaningful advantages. This shapes how often, where, and why it would be used. In real-world scenarios, advanced fighters are typically reserved for missions where complexity and risk are highest. These may include operations in contested airspace, early phases of conflict, or missions requiring advanced sensing and coordination. The Su-57 fits naturally into this category. Its design suggests use in roles where situational awareness, flexibility, and survivability are critical. Rather than replacing large numbers of existing aircraft, it complements them by handling tasks that benefit from higher capability. One likely role involves operating alongside other aircraft types. In such scenarios, the Su-57 could contribute sensor data, help coordinate engagements, or perform specialized tasks while more numerous aircraft handle routine missions. This layered approach maximizes overall effectiveness while managing risk and resource constraints. Another important factor is geography. Aircraft are designed around the environments in which they are expected to operate. Large distances, varied terrain, and contested regions place unique demands on air forces. The Su-57's range and flexibility support operations across wide areas without constant reliance on forward bases. This allows it to operate from secure locations while still contributing to regional missions. Real-world use also depends on the level of threat. In lower-risk environments, advanced capabilities may not be necessary. In higher-risk environments, they become more valuable. This means the Su-57 would likely be deployed selectively rather than continuously. Such an approach preserves readiness and ensures availability when its capabilities are most needed. Another practical consideration is coordination with other systems. Modern air combat is not about individual engagements, but about synchronized actions across domains. Fighters, ground defenses, and support assets must work together effectively. The Su-57's role within this system is to enhance coordination rather than act independently. This may involve supporting air defense operations, contributing to area denial strategies, or assisting in complex missions that require advanced awareness. It is also important to consider how such aircraft influence planning even when not actively engaged. The presence of advanced capabilities can shape how potential adversaries plan operations. This indirect effect can be as important as direct combat use. From a practical standpoint, advanced fighters are also influenced by sustainment and readiness considerations. Maintenance requirements, training demands, and logistical support all affect how frequently an aircraft can be deployed. These realities reinforce the selected use model. Rather than being constantly in the air, aircraft like the Su-57 are likely held in reserve for missions where their value is highest. For American audiences, this concept aligns with how advanced platforms are often used. Even highly capable aircraft are not employed indiscriminately. They are integrated carefully into broader force structures to maximize impact. Understanding this practical use helps move the discussion away from abstract comparisons and toward realistic assessment. The question is not how the Su-57 would perform in isolation, but how it would contribute within a complex operational system. This perspective clarifies why advanced fighters are designed the way they are and how they fit into real-world military planning. As the documentary continues, this practical understanding will help frame comparisons and evaluations more accurately. Modern air power is not defined by individual aircraft acting alone, but by how effectively systems work together under real-world conditions. Comparing modern fighter aircraft often creates more noise than insight. Search results, headlines, and online discussions frequently reduce complex systems to a single question: which fighter is better? While this framing attracts attention, it rarely leads to understanding. Aircraft like the F-22, F-35, J-20, and Su-57 were not built to win abstract contests. They were designed to meet specific needs, shaped by the priorities, constraints, and assumptions of the air forces that operate them. Understanding those priorities tells us far more than any single performance metric. The F-22 Raptor provides a useful starting point. Developed during the final years of the Cold War, the F-22 was designed primarily to secure air superiority against advanced adversaries. Its emphasis on stealth, high-altitude performance, and integrated sensors reflects a doctrine focused on gaining control of the air early and decisively. Produced in limited numbers, the F-22 is used selectively, reserved for scenarios where its unique capabilities provide maximum advantage. The F-35 Lightning II represents a different approach. Rather than focusing on a single mission, the F-35 was designed as a multi-role, network-centric platform. Its defining strength lies in sensor fusion and information sharing, allowing it to act as a node within a broader combat system. The F-35 reflects an Air Force priority on coalition operations, information dominance, and interoperability across services. China's J-20 adds another perspective. The J-20 is widely viewed as emphasizing long-range operations and forward presence. Its design suggests a focus on extended reach, area control, and the ability to influence operations across large regions. This reflects strategic assumptions tied to geography and regional priorities rather than a desire to mirror Western designs. The Su-57 fits into this landscape as yet another interpretation. Rather than maximizing a single attribute, the Su-57 balances reduced observability with speed, maneuverability, and flexibility. Its design reflects an assumption that future combat environments will be complex, contested, and unpredictable. Rather than acting alone, it is intended to operate as part of a layered system alongside other aircraft and defenses. These differences highlight why direct comparisons can be misleading. Each aircraft was designed around different questions. The F-22 asks, how do we dominate the airspace? The F-35 asks, how do we integrate information across forces? The J-20 asks, how do we project influence over distance? The Su-57 asks, how do we remain flexible across uncertain conditions? None of these questions is inherently superior. They reflect different strategic priorities. This is why rankings and simplistic comparisons often fail. They ignore context. They treat aircraft as interchangeable products rather than components of larger systems. For viewers, especially American audiences, understanding this distinction is essential. It reframes comparisons as exercises in understanding doctrine rather than declaring winners. This perspective also explains why debates framed around who would win rarely produce meaningful conclusions. Modern air combat outcomes depend on far more than aircraft characteristics alone. Training, coordination, support systems, and operational context all play decisive roles. By focusing on priorities rather than rankings, we gain clearer insight into how different air forces think about air power. This approach reduces friction, encourages thoughtful discussion, and aligns more closely with how real-world military planning actually works. As the documentary moves forward, this understanding provides a foundation for examining limitations, evolution, and future trends without resorting to oversimplification. In modern military aviation, context matters more than comparison. Like all modern aircraft, the Su-57 faces limitations. This reality is not unique, and it is not a flaw in itself. Every advanced military platform enters service as part of an ongoing process rather than a finished product. Understanding these limitations is essential for evaluating credibility and long-term relevance. For American audiences in particular, honesty builds trust. Rather than asking whether an aircraft meets idealized expectations, a more useful approach is to examine how production realities, sustainment demands, and system maturity shape its evolution over time. Production scale is one of the most visible constraints. Advanced fighter aircraft are complex, expensive, and resource-intensive to produce. As a result, they are rarely built in large numbers. This naturally influences how they are deployed and how central they become to overall force structure. The Su-57 reflects this reality. Rather than replacing older aircraft across the board, it is positioned as a selective capability. Limited production encourages careful planning and targeted use, ensuring that the aircraft is available when its capabilities provide the greatest value. Sustainment is equally important. Modern fighters rely on advanced materials, software-driven systems, and sophisticated sensors. Maintaining these capabilities requires specialized infrastructure, training, and logistical support. These sustainment demands influence readiness rates and operational tempo. They also shape how frequently aircraft can be deployed and how long they remain mission-ready. The Su-57 is designed with these realities in mind. Its development prioritizes durability and adaptability rather than maximum performance at the expense of long-term support. This reflects an understanding that availability over decades matters as much as peak capability at any single moment. System maturity represents another critical factor. Modern aircraft are increasingly software-defined. Capabilities such as sensor integration, data processing, and electronic systems evolve through updates rather than hardware changes alone. Early versions often focus on core functionality, with additional features introduced gradually as systems mature and operational experience grows. This incremental approach allows designers and operators to refine capabilities based on real-world feedback rather than theoretical assumptions. The Su-57 follows this pattern. Its evolution depends on continued refinement, integration, and learning. As experience accumulates, adjustments can be made to tactics, systems, and support structures. This process is not unique. Many modern fighters undergo similar cycles of development and improvement. What matters most is the ability to adapt rather than the absence of limitations. Another important consideration is how future upgrades are prioritized. Resources are finite, and decisions must be made about where improvements deliver the greatest return. Software enhancements, sensor upgrades, and integration with emerging systems often provide more flexibility than structural redesigns. The Su-57's design supports this kind of evolution. By functioning as a platform rather than a static solution, it can incorporate new capabilities as technology and doctrine evolve. From a credibility standpoint, this perspective matters. No aircraft remains static over its service life. Those that remain relevant are the ones that adapt effectively to changing threats, budgets, and operational needs. The most important question is therefore not what the Su-57 is today. It is how it adapts over time. This long-term view provides a more realistic basis for evaluation. It allows observers to move beyond headlines and focus on how modern military systems actually develop, mature, and improve. As this documentary approaches its conclusion, this understanding helps frame the Su-57 not as a final answer, but as part of an ongoing process. Its limitations shape its present role. Its adaptability will shape its future. In modern air combat, evolution is not optional, it is essential. Modern air combat is entering a new phase. For much of aviation history, the focus has been on the relationship between a pilot and an aircraft. Skill, training, and individual performance played central roles in determining outcomes. Even as technology advanced, the aircraft itself remained the primary unit of action. That model is changing. Today, air combat is no longer just about pilots and aircraft. It is increasingly about humans working with machines, coordinating multiple systems, managing information, and making decisions in environments shaped by speed, complexity, and uncertainty. This shift defines the future of air power. To understand what comes after today's fighters, it is necessary to move beyond the image of the lone pilot and examine how modern aircraft are becoming nodes within larger, interconnected systems. In this emerging model, aircraft do not operate alone. They operate as part of teams. These teams may include crewed fighters, uncrewed aerial vehicles, distributed sensors, and command and control systems, all linked through networks that allow information to flow rapidly between participants. The goal is not to replace pilots. It is to expand what pilots can do. One of the most significant changes is the move away from single aircraft missions toward team-based operations. In earlier eras, aircraft were often tasked individually or in small formations, each pilot managing their own sensors, weapons, and situational awareness. While coordination existed, it was limited by communication bandwidth and human workload. Today, advances in networking and automation allow a single pilot to oversee far more than one aircraft. This is where the concept of human-machine teaming becomes relevant. Rather than acting as direct substitutes for pilots, machines increasingly serve as extensions of human decision-making. They collect data, perform routine tasks, and present information in ways that support faster, more informed choices. In this framework, the pilot's role evolves. Pilots become decision managers rather than purely manual operators. Instead of focusing primarily on flying the aircraft, they focus on interpreting information, prioritizing actions, and coordinating assets. Automation handles many lower-level tasks, freeing cognitive capacity for higher-level judgment. This shift mirrors trends seen across many technologically advanced fields. In complex systems, human strengths lie in adaptability, intuition, and contextual understanding. Machines excel at processing large volumes of data quickly and consistently. Human-machine teaming seeks to combine these strengths. Uncrewed aerial systems play a central role in this evolution. Rather than acting independently, future uncrewed platforms are expected to operate alongside crewed aircraft, extending sensor coverage, carrying additional payloads, or performing specialized tasks. In this model, crewed fighters act as command nodes. They direct, coordinate, and integrate uncrewed systems into broader missions. This expands reach and flexibility without placing pilots in unnecessary risk. Importantly, this concept is not tied to any single country. Air forces around the world are exploring similar ideas, driven by the same pressures, contested environments, rapid decision cycles, and the increasing importance of information. The specifics may differ, but the underlying logic is shared. This makes human-machine teaming a global trend rather than a national one. Artificial intelligence plays a supporting role in this transformation. Despite popular portrayals, AI in air combat is not about replacing pilots or automating lethal decisions without oversight. Instead, AI is best understood as decision support. It helps filter information, identify patterns, and suggest options. It reduces cognitive overload in environments where human attention is limited. Final decisions remain human. This distinction is critical for understanding the direction of modern air power. The value of AI lies not in autonomy for its own sake, but in enabling humans to operate more effectively within complex systems. Aircraft designed today must accommodate this reality. They must be capable of integrating new software, managing increased data flows, and interacting with uncrewed systems that may not yet exist. This is where adaptability becomes a defining design requirement. Platforms that are rigid or difficult to upgrade risk obsolescence. Those designed with growth in mind are better positioned to remain relevant. The Su-57 was developed during the early stages of this transition. Its design reflects an awareness that future combat environments would demand coordination, flexibility, and system-level thinking rather than isolated performance. Rather than being optimized solely for one mission profile, it was conceived as part of a broader operational ecosystem. This does not mean it was built specifically for human-machine teaming as it is envisioned today. But it does mean its architecture allows for growth. As concepts evolve and technologies mature, aircraft that can integrate new capabilities without fundamental redesign gain strategic value. For American audiences, this perspective aligns with broader trends in defense planning. Future force structures increasingly emphasize integration across domains. Air, land, sea, space, and cyber systems are expected to operate in concert rather than isolation. Human-machine teaming fits naturally within this framework. It supports distributed operations, resilience under attack, and adaptability in uncertain environments. As these trends continue, the most important aircraft may not be the one with the highest individual performance, but the one that best coordinates the team. Coordination becomes power. The ability to integrate sensors, share information, and direct multiple assets allows forces to act coherently in environments where speed and complexity challenge human limits. This reframes how we think about air combat. Rather than asking which aircraft is superior, a more relevant question emerges. Which aircraft can best enable teamwork? Which platforms can adapt as systems evolve? Which designs support human decision-making rather than overwhelm it? In this context, the future of air combat becomes less about individual machines and more about relationships between them. Humans remain central. Machines expand capability. Together, they form systems that are more flexible, resilient, and effective than either could be alone. As this chapter concludes, one idea stands out. The future of air combat is not human versus machine. It is human with machine. And if the future is teamwork, the most important aircraft may be the one that coordinates best. After examining the Su-57 from multiple angles, its context, design philosophy, capabilities, limitations, and future potential, one question remains. What should viewers actually remember about this aircraft? Not the headlines. Not the comparisons. Not the arguments. What matters most are the lessons the Su-57 offers about modern air combat itself. This final chapter distills the documentary into a set of clear takeaways. These are not judgments. They are observations grounded in strategy, engineering, and systems thinking. Taken together, they help clarify what the Su-57 really represents. The first lesson is that aircraft reflect doctrine, not ego. No modern fighter is built simply to impress or to compete symbolically. Aircraft are shaped by the strategic assumptions of the air forces that design and operate them. Geography, threat perception, budgets, alliance structures, and historical experience all influence design choices. What emerges is not a universal solution, but one optimized for a particular way of thinking about conflict. The Su-57 reflects Russian assumptions about air combat, assumptions shaped by large geographic spaces, layered defenses, contested environments, and the expectation that conflicts may be unpredictable. Understanding this helps remove emotion from analysis. Differences in design are not evidence of weakness or superiority. They are evidence of different priorities. The second lesson is that fifth generation is a philosophy, not a checklist. Throughout the documentary, the term fifth generation has appeared repeatedly. It is often treated as a binary label, either an aircraft qualifies or it does not. In reality, fifth generation describes a shift in mindset. It reflects the move toward integrated systems, information dominance, survivability through layers, and adaptability over time. Different air forces emphasize different aspects of this philosophy. Some prioritize low observability above all else. Others balance stealth with speed, maneuverability, or flexibility. Still others emphasize range, networking, or endurance. The Su-57 reflects one interpretation of these ideas. It does not copy Western designs, nor does it reject fifth-generation concepts. Instead, it adapts them to a different strategic context. The third lesson is that systems matter more than specifications. In popular discussions, aircraft are often reduced to numbers: speed, range, radar cross-section, payload. While these metrics are useful, they rarely determine outcomes on their own. Modern air combat is shaped by how systems work together. Sensors, networks, command structures, training, logistics, and doctrine all play decisive roles. An aircraft's value depends on how effectively it contributes to this larger system. The Su-57 is best understood as part of such a system. Its design emphasizes coordination, flexibility, and integration rather than standalone dominance. This mirrors a broader truth about modern warfare. Victory is rarely achieved by a single platform acting alone. The fourth lesson is that adaptability beats perfection. No aircraft enters service as a finished product. Modern fighters are increasingly software-defined, evolving through updates, integration, and operational experience. Capabilities change over time as threats evolve and lessons are learned. Perfection at launch matters less than the ability to adapt over decades. The Su-57 reflects this reality. Its long-term relevance will depend not on initial comparisons, but on how effectively it incorporates new technologies, adjusts tactics, and integrates with emerging systems. This lesson applies universally. In fast-changing environments, flexibility often proves more valuable than optimizing for a narrow set of conditions. The fifth lesson is that context explains differences better than comparison. Comparisons between aircraft are inevitable. They can be useful, but only when grounded in context. When comparisons ignore doctrine, geography, and intended use, they generate more confusion than clarity. They encourage debates about who is best rather than understanding why differences exist. The Su-57 highlights this problem. Viewed without context, its design choices can seem puzzling. Viewed within context, they become logical. This reframing changes the nature of discussion. Instead of asking which aircraft is superior, we begin asking more meaningful questions. What problems was this aircraft designed to solve? What assumptions guided its design? How does it fit within a broader system? These questions lead to insight rather than argument. Taken together, these lessons point toward a broader conclusion. The Su-57 does not answer the question who is best. It answers a different question. How many ways can modern air combat be approached? The answer is not one. Modern air power is not converging on a single solution. It is diverging into multiple approaches shaped by different constraints and priorities. This diversity is not a weakness. It is evidence of adaptation. As technology advances and environments become more contested, no single model will dominate indefinitely. Air forces will continue to experiment, adjust, and refine their approaches. Aircraft like the Su-57 are part of this experimentation. They are not endpoints. They are waypoints. For viewers, especially American audiences, this understanding sharpens perspective. It encourages analysis without rivalry, interest without exaggeration, curiosity without judgment. Understanding different approaches doesn't weaken perspective. It sharpens it. That is the most important takeaway. And it is the lens through which the Su-57 is best understood.